Apache Spark is a popular framework for large-scale data analysis, but is known to be inefficient compared to MPI, the gold standard for high-performance distributed computing. For example, the generation of the data underlying this visualization of a principal component of the 3D ocean temperature field takes about 20 times longer in Spark than in MPI. Alchemist is a framework that facilitates calling MPI codes from Apache Spark. It uses dynamic linking to load the relevant MPI libraries as users call their functionalities and manages the transfer of data back and forth between MPI and Spark. Here we see an example of using Alchemist to read our climate data in HDF5 format. First, we launch a 20-node allocation on our local supercomputer. We then start Alchemist in the background on 10 of these nodes and use the remaining nodes to run Spark. Now we start the Spark shell and tell it to load the Alchemist jar. We import the Alchemist functionality and connect to the Alchemist MPI processes. Then we define the files we'll be reading from and writing to and the name of the variable containing our climate data inside of the file. Our first call to Alchemist tells it to read the climate data. It stores this as a distributed matrix on the MPI side and returns a handle for Spark. Our next call retrieves this matrix from the MPI side to Spark as an indexed row matrix object. This transfer of 400 gigabytes takes slightly more than a minute. Now we write this file out to Parquet format so that in the future we can load it in Spark without using Alchemist. This writing also takes about a minute. Finally, we close down Alchemist and exit Spark. Of course, Alchemist can do much more. For example, here we compare the time to compute SVDs at various sizes using Alchemist, including the data transfer times, to the time to compute SVDs using Spark's implementation. We see that Alchemist is much more efficient. See our poster for more details and performance comparisons.